Hello everyone, and I have been learning stylized VFX for a month and I have been practicing a lot. You can see like a very random stuff that you could see on this page. I've been following different tutorials and also trying something on my own, and I just realized one thing, that finding a good tutorial which starts from the start, like very basic, and explains what we are doing is not possible. Like there isn't any video which goes into like basics and then slowly starts progressing one by one, and that is my goal of this series. So in this video we are just going to learn about the basics of materials and fundamentals, where we will learn how to combine the materials to create our own shape and like this animations all in material. And the thing is, I have been practicing a lot like this. You could see very random stuff which I have been checking on like the GDC talks and all, where they explain, and trying it myself. Even if you're using any other engine or just using Blender or any other software like Material Maker, which is like a free substance designer alternative, everything which I'm going to teach you today applies to that thing. Okay, it doesn't have to be just this engine, which is Unreal Engine. Even in Photoshop you can actually apply the fundamentals that I'm going to teach you today. So let's get started. And one thing you guys need to realize, that when you are doing a VFX, it is not just a material, or it's not just a particle, or it is not just a mesh. It is actually combination of multiple stuff. For example, this one is actually a mesh. If I show you, this is a mesh which is actually been distorted, and then a material or a texture is just moved. So this is also a stylized VFX kind of shot. Even though I'm not using Niagara particles, this animation still looks nicer. And you could see in this one also, I'm not using Niagara particles, but this is actually a mesh that I have, and I'm just making a material go like this. Similar to this one, you could see that this is actually just a sphere mesh, two of them actually, and then you could see that this is actually transparent wherever there's black. And if you go in here, this one is only Niagara emitters. So if you check in here, this is only Niagara emitters, but actually it is still using mesh. But the thing is, when you go into Niagara emitters, and again, don't worry if you don't understand this, we will learn this in future, but I still want to show you some basics. So if you check the sprite renders, you could just think of it as something that is spawning planes. So let's say if I go in here and add an emitter, do some spawn rate of 50, you could see that I am actually spawning a circle because that is the mesh. But if I remove this one, you could see I am actually spawning a plane. So we are using a mesh in here too. So the thing is, we are using mesh whenever we use Niagara particles already, because by default it creates a square which is using a sprite or a material basically, which is called a sprite, and this thing will always face us when we use Niagara emitters. So one thing to let you guys know, that when we try to create something, when you're working with stylized graphics or just normal VFX, it is not just material, it is not just mesh, it is not just Niagara emitters or particles or system. It's basically combination of all of them, and what you use and how many of the components that you use is completely dependent on you. And obviously there's also blueprints and all, where you can actually attach some functionalities on when it should spawn and all. For example, when a player does an attack or heal, then this should just basically spawn, and that is controlled by our blueprints. So let's learn and get started. I actually have a website which would be available for you to watch. This is called My Use Guide to VFX Fundamental and Techniques. I am working on making this, you could see. So one thing I want you guys to know, that even though I'm making this video now, I was actually planning to make this like way later, because I thought I should probably learn a lot, but considering how much I've seen, there would never be enough for me to be like, hey, this is now enough for me to teach, which is why I'm just going to start. And as I learn in future, I will create even a better video, and I'll link it in description. So make sure to check the description if there is a better video available or updated video available. But for now, let's just get started. So first thing you guys need to know, that what is UV coordinates. So first of all, I'm going to go into my folder and create a material. I'll just call it as tutorial. Open this material, and I'll select this plane, so we see this material on plane. If I add a texture coordinate, if you press U and do left click, it will add this automatically, or you could search by doing right click and add this. If I add this to my base color, you could see how this looks. I'll also make the specular to be 0 and roughness to be 0.9 so that we can see it better. Now you could see this is what we get when we connect our texture coordinate or UV coordinates into a plane, which is just a square, and this square is basically 1 by 1. So for example, if we go into the basics of UV coordinate in my page, you could obviously check it in the description. You would see that we start from 0, 0, and this is just a graph. Okay, so this is just a basic graph which you have learned in school, where it goes from 0, 1, 2, 3, 4 in the x-axis, and then 0, 1, 2, 3, 4 in the y-axis. And one more thing you might notice, that even though we are going below, we are considering it as positive because in Unreal Engine it is made that way. But if you were using Unity, you can see that it looks a bit different, right? It does not start from 0, which is this black area. Okay, so this completely black is 0, 0. Let's say it starts from here and it goes like 0, 1 and 0, 1 on the top, and it would go like 0, negative 1 at the bottom. But for us, when we are using Unreal, it goes 0, 1 at the bottom and then 0, 1 at the right side. Again, doesn't really matter. It does not matter. It's not going to like change any crazy stuff. You don't really need to think of it much. So we have learned one thing, that when we go at the right side, which is like x-axis, we simply go from 0, 1, then 2, 3, 4 at the right side. Obviously, when we go negative, it would be -1, -2, -3. And when we go bottom, we go 0, 1, 2, 3. And obviously on top, it's -1, -2, -3, which is basic graph of math. And when we say UV, it doesn't really matter because it is just X and Y. Okay, that's all you need to know. So as we go down, you can see that this is something that I made in Blender, and you could see that it is 0, 0, 1, 0, 2, 0, 3, 0 like this. It's actually this point. So this point is 0, 0, this point is 1, 0, 2, 0, 3, 0, 4, 0 like this, even though it is set in center. What it actually means is that it basically tells that this point should actually use this UV coordinates in the 2D space. And this point is actually this point in the 2D space, this point is this point in 2D space. So this texture, like this part, this triangle in the UV is actually applied to this triangle. So UV would basically help you to project a 2D texture on 3D mesh. And we basically use these coordinates to basically tell that this is the vertex point where it should basically use this much of the texture. I hope this is understandable in this scenario. It's just the 0, 0, 1, 0, 0, 1, 1, 0, like the whole UV coordinate. And this part is just using like this coordinates of the texture. So now we actually know that this is basically 0, 0 and this is basically 1, 1. So it goes from like this 0, 0 to 1. And you know, when we say UV, it's actually 2 points, right? Because U and V. Just know that if you go into this, what do you call it, this pin, and say breakout float 2, because we know that there is 2 points in here because U and V. This would basically give us U and V. And again, it doesn't matter what it is said in here. You could see it doesn't matter. All it simply matters is the value or float value, and it doesn't matter it says RGB or XY or UV. Nothing matters when or what this pin means. It all matters is what you will use these values for. So for example, our UV around here is 1, 0, which means this would give us 1 and this one would give us 0 at this point. So again, what you do with these values is completely dependent on your choice. It doesn't matter what it says. So if I connect the U channel in here, you can see we get left to right. And again, if you cannot see the environment, this is how if you go to Windows and do preview settings, you can actually disable the environment. It's good when working with sprites and all, but for now, let's just keep it. And you could see it goes from left to right because U goes left to right. So it goes from 0 to 1. Remember that. And when we are talking in values like 0 and 1, when it comes to a texture, anything that is 0 is black and anything that is 1 is white. If I go into my page, if I scroll down a lot, I'll explain this slowly, but let's go below. Around here, you could see that Grayscale Textures. Grayscale Textures are nothing but a texture which has different values at different pixel locations. So 0 is black. So you could see I've said that this point around here is completely black, so it is 0. this point is completely white. It is 1 at this particular location, and this one is slightly in middle, so it's 0.5. This one is slightly around here, so around here, let's say 0.4, and this one is around here, so it's 0.8. So it goes from 0 to 1, and you could see one thing, that as we go from 0 to 1, it gets more and more whiter. So 0 is black, 1 is white. That's all you need to know. And another thing is, you can see that we have metallic, specular, roughness, and here we can actually add values like 0 to 1. 1 is basically like fully rough, and 0 is like no roughness. Specular is like fully specular, like fully reflective kind of stuff, and then 0 is no specular, which means that when we add a texture, whenever we add a texture in here, like a roughness map or anything which is a black and white color. For example, if I add a texture sample and I will use a cloud map which I made, and again I will explain a bit of this. So if I click on this texture, this is the texture that I'm using. The thing about this texture is, it's not just one texture, it is actually 3. It is called a packed texture. Packed texture is nothing but where you can combine 3 different texture in one singular image. Just think of it as, instead of creating 3 different grayscale images, we just made one single image, and we can just simply isolate each image by simply saying that our channel should have this one. So this is the one grayscale image. If I go to G, this is the second image, and you could see that these are different. You could see. And then we have B channel, which is a slightly blacker color like this, which means that I can create 3 different grayscale textures and put it in one single image. And this way I don't have to like make 3 different texture images and then like try to search and find each one of them. I can simply just add 3 of them in one, and it just works. Just remember, it is not something that you do for colored images, you only do for black and white. So for example, if you want to have one single texture which has specular, roughness, metallic, or even ambient occlusion, like 4 stuff you could add in here like this in one single image, so that you don't have to create 4 images and then place it like this. And obviously RGB gives like the whole image, but if you just use R, it will give us the black and white image, which is this one. And remember what we said, that black and white image just gives like 0 and 1 values. So when you go RGB like this, then we get like 3 values, just going like 0.5, 0.3, 0.7, like that would be RGB, like 0.3, 0.7, 0.8, like this, which would give basically a color. For example, if I select an image and select a color like this, you could see we get 0.4 like this. So all of these are three values, like float 3, and this one basically would give us only the one channel or one value or one float. If you don't know what float is, just think of it as one single number which has decimals. So this is basically float, like 0.0, 1.1, 1.5, anything that you want, like this is float. And obviously if you create, let's say 2 of them, and then you could search for, let's say, make float 2, this would basically turn this into 20.4, 69.06 and all that stuff. But when we use just R pin, we can simply just say add it in the roughness like this, and then maybe add it in the specular, and you could see we get like some weird shininess. And the reason for that happens is, you probably already know this. Let me remove this. Let's add this like this completely, and you could see this is how it looks. It's basically using this as a roughness. Wherever there is 0, which is black, it's basically making a no reflections. Wherever there is 1, it is making fully reflections, and wherever there's 0.5, it's like 0.5 value, like not as much reflective. So that's one thing you guys need to understand, okay? That when we use one value, we are just getting float 1, and it's same as adding, let's say 1. You could see fully reflective or 0.5, but instead of adding it to full stuff, like adding it fully to the whole mesh, we are adding it to just that particular sections of particular pixel on the mesh. So when we use this breakout float and we do R like this, we get 0 to 1 values, which means that we can use this to, let's say, do some specular roughness and all that stuff. And when we use G, we basically get top to bottom, because it starts from 0 to 1. Like, remember how I said that it goes from 0 to 1. So obviously 0 is black, 1 is white, and anything in middle is like this. And obviously if you do 1 minus, it will basically do opposite like this, because 1 minus whatever value we get around here. So we learned how to isolate U and V. Then we are going to learn what is tiling. Tiling is very basic concept. It's basically when we add a texture into this. For example, if I add my base color of the R channel, we get this texture which is going from this to this. Well, but the thing is, the texture actually repeats everywhere, like in each direction. And the thing is, this is how much our texture is showing on this plane right now. Okay, it's showing 0 to 1 1 like this. So 0 to 1 1. But the thing is, the texture is actually repeating like this in this direction, also on top, also on the left, and also at the bottom. So this texture, it is just this grid, like very big grid, and you are basically saying that only use this much part. Also, there's no gap like this. Okay, this image is just for visual purposes, but there is no gap like this between each texture. So you could see it goes from 0 to 1, then 1 to 2, 2 to 3, 3 to 4, 0 to 1, 1 to 2, 2 to 3, and it keeps repeating. Even in the negative direction, the texture would repeat. Even in the negative direction, the texture is repeating. The thing is, if you go to your texture and actually, I don't remember where is it, but you can actually make it not be repeating. I don't remember, so let's just I don't remember where to like make it clamp. There's something called clamp. I haven't really used it, but it is option somewhere around here where you could say that don't repeat the texture. So basically when it reaches this, it will basically just stop. And another thing is, when you create a texture, always create in multiples of 4 or divisible by 4, because let's say 2048 by 2048, like 512 by 512, 1024 by 1024, like that. Because when you add a texture in that size, then your Unreal Engine will create MIP maps. You could say number of MIPs 12. Obviously you could go in here and say like no MIP maps. Basically it will not generate MIP maps. And what MIP maps are, basically it will take this texture like this and it will create a smaller or half version of it. Okay, so it will basically take this texture, and if I, let's say, select this, you could see it slowly starts making it smaller and smaller, and it just basically does half and half and half kind of stuff. You could even check around here. So if we go to 0, it is the full size 2048. If I do in here, it goes 1024. And this MIP maps basically is a way to optimize your game or scene, where when you're further than this image, or when you're further than this texture, then it would basically load a smaller MIP maps. And it also creates like, it also makes sure that it works and looks nicer when you're doing some VFX and some settings, which is why I recommend it to always create something which is divisible by 4, like 256, 512, 1024 to 2048, multiplied by 2 again. I don't remember, but yeah, keep repeating. I know we haven't really started doing like cool stuff, but just keep watching. I need to make sure you guys understand this so that we can proceed. Tiling as texture is basically just, taking this repeating texture, which is like this. You could see this is 0010, which is just showing one image on this particular square. So how we can make it tile? So for this, we can actually connect let's remove our breakout float and take this UV coordinate, which is going from all the both of this value, which is U and V, and basically connecting it here would do no difference because this one is automatically using this coordinate system. If I type multiply, or you could press M and do left click, or just search for multiply. If you multiply this with UV with 1, nothing's going to happen. Why? Because multiplying anything by 1 does no changes. 2 times 1 is 2, 5 times 1 is 5, 10 times 1 is 10. So no changes. If you do 0, it is just going to mess it up. If you do 2, guess what's going to happen? Maybe I should use a different texture for this one so that it's much more easy to understand. So let me just see if I have something that works nicer. So this is what I'm using. Okay, so this is a leaf texture that I have. If I do 2, you could see it is now repeating 2 times. And why is that? Because think of it this way. Because if you look at the UVs, what would happen if you multiply 0 and 0 with 2, which we are doing around here? It will turn 0, 0. What would happen if you multiply this? It would turn 2, 0. This would turn to 2, 2. This would turn to 0, 2. Which means that our coordinate or UV system is now taking from 0, 0 to 2, 2 like this. When you multiplied, the UV is basically just stretched like this, and it is taking the image which is like this much, which is like double size. And obviously this means that if you do 5, it would basically repeat it 5 times. So 1, 2, 3, 4, 5 and all that stuff. On the opposite way, if you do 0.5, which is same as dividing by 2, right? Because 0.5 can also be written as 5 by 10. And 5 by 10 is basically 1 by 2, which is same as dividing this by 2. You could see something just happened, which is when we multiplied it by 5, or you could even do like divide by 2, this is same. It is going to basically turn this into this stuff, which is 0, 0, 0.50, this stuff. So basically it was from till this to this, right? And it basically shrinked it this much. So we are now using only this part. So you could see, do 0.5, it is now only using the image of that area only. So if you do something that is like 0 to 1, between 0 to 1, then you are basically just stretching it. If you do -1, you can see it kind of flipped it. If you do -5, it is going to be 5 times, but it is basically flipped. So just know that when we do a multiplying, we are basically just playing with the UV coordinates and this grid system, which we have 0, 0 and all that stuff, or this graph system, and we are just making it left and right. Now we have something called tiling texture in specific axis. Remember what we did to actually get both of these values, because this is U and V. So when we are multiplying it by 2, we are multiplying both of this stuff. So if I do breakout, float to components, or there are actually multiple ways to do the same stuff. Just because I'm saying do this and maybe you watch another tutorial, or maybe you found your own method that does the same thing, doesn't matter what you do as long as you get the values. For example, you could also search for component mask, and if you open this, we get like all these options, and here we could say that only give me R channel, which is same as saying that give me only U channel. Here you could say give me only V channel, and obviously there is nothing in B and A, so this would basically do nothing. So there are multiple ways to just get the values. You need to think of it as a number, and what we are basically saying that we are taking the two numbers that we have, and we are basically getting one of it, which is getting this is float 2, we are getting float 1 and float 1 separately. And what you do with this value is completely up to you. It's not like a specific usage. You could do anything that you want with this. You just need to know that this is two values. Now if I connect this R around here and look in here, you could see it just messed up. Why did it mess up? Even though it says 1, right? And anything multiplied 1 should not do anything. Well, it's simple, because this thing requires UV. Okay, it requires UV. Here we are taking UV, we are saying, hey, give me only U, and we are multiplying the U with 1. So instead of providing it with UV, which is 2 floats, we are only providing it with one float. And when we use one float and add it around here, it's basically using the same number twice. Okay, so just know that thing. And this is very basic thing about Unreal Engine, where if you press 1 and do left click, we get float 1. If you do 2, then float 2, 3, float 3, which is 1, 2, 3. And you could see this is also used for color, because in the end this is just a color, because in the end we can use this for a color or also for vector or anything. And with 4 we get like 4 values, which is alpha and all. So one more thing is that you cannot do, let's say, a multiply or any other math operation with float 2 like this with float 3. It has to be float 2 and float 2. It has to be float 3 and float 3. But when it comes to float 1, you could do it with like this. So you could connect this and you could do this math, because this would basically multiply it with both of these values. So float 1 can be multiplied, added, subtracted to any math with any of the other floats, but when it comes to float 2, float 3, they have to be their own floats. Okay, so just know that. So float 2, float 2, float 3, float 3, no float 2, float 3 like this. Okay, I hope that is not confusing. This is just the reason why I'm saying all this is because I struggled with it when I started learning. Okay, so I want to be much more detailed and thorough with this tutorial. Now the thing is, we did break out float to components. We could actually do make float to vector, which is make float to. This would basically turn into, if I connect this, it's basically going to give us u and v, because this would turn into two values because we are converting into float 2. But for this, we will need to do is, we will need to connect this value around here, and you could see we are now working perfectly. So we took our texture, we took our coordinates, we broke it into two different values so that we can only control the r value. We took that, and then we are saying that, hey, make this again without changing the g value. Another way that you could do, which I like to do, it's a better way I think, because it reduces the amount of nodes that are required. You basically multiply it directly. This is uv, and instead of having this one as a one singular value, because this is float 2, right? Because u and v, if I open this u and v, I could simply create a float 2, but the problem is if you convert this to parameter and all, it turns to float, it turns to this float 4, which is kind of annoying, which is why I just create a 2 single floats and use something called append like this, or use make float 2. This 2 would do the same thing. Okay, so let's use make float 2, and this would basically turn into float 2, and if I multiply this, we are multiplying two values with two values. Okay, so 1 and then connect this. So you could say this is a bit better and concise way to make something. And again, this whatever it is around here, which is x, would only be applied to u, and whatever is applied around here would only be multiplied with v. So instead of actually breaking it and doing it separately, we can just multiply float 2 with float 2. Now if I do, let's say 2 in here in the x-axis, you could see something just happened. Instead of multiplying it on the top and bottom 2, we are just multiplying it 2 times around here. Let's go down, and you could see texture tiling in u and v. So remember the math that we did before, which was 0 0 1 0. When we multiplied with 2, we were multiplying both of these values with 2, right? But right now what we are doing is we are only multiplying the x with 2. So it would be 2 0, which is 0 0, multiplied this would turn into 2 0, this one would turn into 2 1, and this would turn into 2 1, because we are multiplying only the x value with 2, which is why this only scales around here like this. It only turns into this big rectangle shape like this. Similarly, if you do 2 right now on the y-axis, it would turn into like this. If I turn this into 1, it will basically make it like this. Usually I have used this for creating like a waterfall or something, where if you use something like cloud texture, which we created previously, and if I do something like 5 50, maybe let's do 1 and let's do 10 around here, you could see it is stretching like this, and we can create like cool shapes with this one, which is something like a waterfall falling or something, if we make it go from up to down like this. Okay, so we learned how to multiply or tile a texture in x and y separately. Now this is where offsetting and panning comes, which is very common stuff that you would use, which is adding or subtracting, which is adding in the UV coordinates, and we use add node to actually move the texture or animate the texture. So instead of using multiply right now, I'm going to remove this. Should I turn this back to leaf? Never mind, I'll keep it like this. I'm also going to remove this down, and here we'll do add. You could press A and add it like this. Add is as a UV coordinates, and nothing's happening. Actually something did happen because we added 1. If we add 0, then obviously nothing's happening, because when we add 0, nothing happens. 5 plus 0 is 5, 10 plus 0 is 10, all that stuff. So adding 0 is basically saying that no changes. But if I do, let's say 0.5, I should use the leaf texture, because that would basically make it easy to understand. Okay, so if I do 0, You could see no changes, 0.5, something happened. And the thing that happened is it goes from 0 to 1, right? 0 to 1 like this. So when we add 0.5, everywhere we added 0.5, and this is what turns for the UV coordinates. So when it started from year to year like this, it started from 0 to 1, 1, it actually just moved in this direction on this diagonally on the bottom right. So it turns into this coordinate system 0.5, 0.5, 1.5 and all that stuff, and it basically moves the texture in this direction because we are just moving the UV points on all of them, on all UV coordinate points. If I do 1, you're going to see no changes. If I do 2, there's going to be no changes. If I do 5, there's going to be no changes, but actually there have been changes. We are basically just moving this point to this point like this. So think of it as moving from this texture space to this texture, which basically is just repeating. So if I use something called time node is basically a countdown. For example, you could think of the time node as this much, like this, where it basically goes from 0 and it keeps increasing as the game progresses. That's all this timer does. If I connect it to the add node, guess what? It's now animating, because this is constantly putting values into the add node, which is in increasing order. And you could say it's basically just moving it like this. Okay, it is basically just giving us a float value, float 1, like the stopwatch that I showed, and just think of it as that number being put into this add constantly. Now remember something that I showed in here, but before that, let's just do one thing. This goes, if I do multiply with this thing, which is the time which is going from 0, 1, 2, 3, 4, 5, 6. If I multiply with 2, it will go from 0, 2, 4, 6, 8, and it will basically be twice as fast. If you do 0.5, it would be slower. If you do 50, it would be like way too crazy. So again, this is the time node is something that you use a lot when we are doing some animations for our texture. You do not really add multiply with the time node. Okay, so because this one would make no sense. By adding a multiply node to a texture, you could say nothing's showing, because it goes from 1, 2, 3, 4, 5, 6 like that, right? And when we saw multiplication, for example, if I add a 1 float, if I do 1, 2, 5, 10, 50, you could say it just starts getting weird. So there's no point in adding time node with multiply. But there is actually one thing that you could do, which is a cool thing that I learned very recently, I would say. So that our time goes like this, right? 0, then 1 and all these float values. What if we can just remove this left number? Then we will basically get 0 to like 0.99 again and again, because just add a hand on the left side like this and just look at the right values. So we will get that values whichever is in the right side, right? For that, you simply use something called frac like this. And if you add frac to multiply, it will never go like crazy, but it will create like this weird pulsing effect. You could see it goes like this 0 to 1, 0 to 1 like this. And I'm getting like sidetracked, but again, there's sine node which you could add like this. I'll explain sine later because it would be a bit confusing if we do right now. Or should I just explain what it does quickly? To explain sine, I'll basically open Paint. Sine is basically a graph like this, which goes from -1 to 1, and sine node basically goes, and sine basically is this stuff like this. Okay, this is sine node, which is going from -1 to 1, -1 to 1, -1 to 1, -1. So it constantly goes from -1 to 1. So when we add a sine node in here, we don't even need to add frac when we use sine node. You could say it's going from -1 to 1 as the time progresses. So yeah, that's all about sine node. I will explain it later or in future videos when we would use sine to create some pulse effect. For now, it would be way too much for newcomers to understand. So let's remove frac, let's remove our multiply node, and let's add our add node again. But before doing that, instead of adding it directly to our add node, which was like this, where it added in the both values, I'm only going to add it in the X value. So let's remove our X. I'll only add to the X and connect it to the add like this. Guess what? It's now only going to move in the left direction, or sorry, in the horizontal direction. And again, if I move it to the left one like this, sorry, bottom one, it will make it go like this. So understand what we are basically doing. If we want to move something on in particular direction, because we have already learned how to break these values into two stuff, we can now just control one of this stuff to animate our stuff. And again, if we just want to speed it up, we can simply add a multiply node, because we want to multiply the time with, let's say, 5, and it would basically move it that direction. And again, you could do -5 if you want to move it in the opposite direction. You could see, so we can simply control how it moves, which direction it moves, and very easily, like which direction and how it moves. But the thing is, you don't really need to add all of these nodes. We actually have something called panner, which you could press P and add it. And if you add it directly like this, guess what? You just have to type a number in here and it would basically do it for you. It already has a time, it already has a UV coordinate, which is this, it already has a speed. But because you have learned more of the stuff, how to break and all, you can actually just do some multiplication around here like this and basically tile it. You can increase the speed by adding a time node around here, multiply it like this, and then add it to the time node like this. It will basically speed it up for you. And because this speed value, we cannot simply just promote this to a variable, because this would basically turn it into one of this stuff. What this basically means is that if you connect it like this and do, let's say, 2, you could say it is adding the same value for X and Y. We don't want that, but we learned how to create like two values, make float 2, and then connect it like this, so that we get both of these values separately, so that we can create two parameters, so that we can use it for our material instance, which is like easy to control stuff for our materials. And that's one thing you guys need to understand, okay, that because we learned all of this stuff, we can now have more control on this panner and know how we can actually play around with it. And again, all of the stuff that I'm teaching is on my website, and I'm also checking what I have to do as per this website that I made, so that I keep in like a good flow. Now we already learned about grayscale texture, where I already said that the black is 0, white is 1, middle is 0.5, and all of this is like the middle values like this. And wherever there is like value required, for example, here we have let's say roughness, right? Obviously, so if I add this into, maybe let's go into this one and convert this into a translucent or masked. Again, if you don't know what the difference is, translucent would allow you to use gray values, which is 0.5, 0.4, 0.3, those gray values basically. Where is it? Like this, gray values. Whereas in masked, it does not take that in consideration. So for this one, you could see that I have 0 everywhere and this is 1. So there is no gray values, or there is no like middle values. It's pure black or pure white. It is pure 0 or pure 1. For this type of material, you would probably use masked, because it's like less, it takes less resources. So if you use masked, we get the option to opacity mask, and I can just connect it around here. And you could see we got the same stuff. And obviously, if you go in here and convert this into translucent, you could see the pin changes, and we can now connect it into opacity. It would work the same way, but translucent materials is actually much more resource heavy, because it allows you to use gray values, right? For example, if I convert this into my cloud texture, you could see that some values are slightly transparent, not fully, and some are fully transparent like this, because there is like 0.5, 0.6 values. But if I go into this again, turn this into masked, you could see there is no gray values. It's completely like black or white. There is no slight opacity. There's also additive, which is basically what we use for for particles like a lot. It basically adds based on, it basically takes also like the background and adds it on top of it, like the whatever the color is it. you know how, the way we did adding around here, the same, the color is added on this top of it like this. I don't really understand additive much, but it's basically just doing addition of the pixels on whatever the behind area is, something like that. Okay, I'm just going to keep it opaque for now. Now we are going to learn the real fun stuff. This is what we usually use for, which is combining textures to create like a really cool stylized effect of just basic VFX or any shaders, anything that you want, not just stylized, even for realistic. So to show you, I'm actually going to use a free software called Photopea. It's like a Photoshop clone, but it's free and works in browser. You could use Photoshop too, but I'm just using it around here because again, I have Unreal Engine and recording on, and my PC would just not work fast if I try to use Photoshop. So this is like a light alternative. If I go in here and then let's say create clouds, we get a noise texture like this. Now just like I showed you before, if I go in here and then let's say do clicks around here, you could see that this B value, which is brightness, changes to something like this. Now the thing is, let me just go in here and paint, I guess, a black spot and a white spot. Now if I click on black spot, you could see the B is 0. If I do here, it's 100, which is like 1. Okay, so 0 to 1. And in the middle, it's like very different values. So one thing you guys already know that it goes from 0 to 1, black to white. And which means that if I, let's say, create another layer, let me add, let's say, another noise crowds. Okay, so this looks different. You could see this is the top one and this is the bottom one. This top layer, if I have to go in here and select, so I just opened Photoshop just to see. Okay, so linear dodge is add. You could see it says in bracket, and we have everything. So we have multiply, we have linear dodge, which is add, we have subtract, divide, and all that stuff. So let me just close this because it's resource heavy. So in here, if I select a linear dodge, you could see something just happen, and which is basically what we did right now. Is if I go in here, we have on the top texture 0 around here and 1 around, maybe like brightest spot is 1, maybe like this, then 0.5, 0.3, 0.1, anything. In here in the bottom texture, we have same values, which is 0 to 1, right? So 0, 1 somewhere around here, 0.5 and 0.6, everything. What's happening is where this black color, which is 0, when we add it around here, it basically is going to say like, hey, do no changes. Why? Because we're doing add, and anything when we add with 0 just gives us the same value. Then we have something, let's say 0.5. So around here, this point, if I, let's say add, let's say if I do add now, not this one, the top one, and what's actually happening is that the pixel value around here is been adding with the pixel value around here, and we are basically getting a value which is like where 0 to 1, or actually even more than 1, because 1 plus 1 can be 2 in this state, and anything above 1 would still be shown as white, anything that is below 0 would still be shown as black. So again, you could see that the pixel values around here are just getting added. So you could even see that the black area, which is 0, will basically just show us this texture. Let me close this. So whatever is around here, it's just going to show the same stuff around here. Why? Because this one has 0 around here. So obviously this texture is what's going to be showing around here, because 0 plus this is just going to give us the value which are around here. Okay, so just remember, we are just adding pixel values. This pixel is adding with pixel, and then whatever the output is, we are basically showing it in a black and white texture, where 1 is closer to white and 0 is black. So if I go and scroll down, you could see this is what's happening. I should have actually explained this way. So let me just go in here and create a color fill or solid color if you're using Photoshop. Turn this into linear dodge. And here, if I turn this into black, you would see that no changes is happening, because we are basically adding it with 0. If I slowly increase this, we are now adding it with 0.1. Okay, so it is brighter. And as we keep going above and above, we are adding more values. So right now it is 0.35. So we are adding 0.35, which means that it's just going to be, you know, brighter and brighter like this. And obviously, if we turn to white, we are just adding 1. So 1 plus whatever the value is behind this. If you check in this example, we are adding 0.3. So wherever there was 0.4, it basically turned to 0.7. Wherever there was 0.8, it turned to 1.1. And you could see that it's basically turning to white and white. I hope this is understandable, where we are basically just adding or doing any mathematical calculation where each pixel of one texture is being added with the corresponding pixel of the other texture. And here you could see that when we add this stuff with here, we can get a bright area like this around here, because again, wherever there is 0, nothing's happening. You could see, because when we add 0 with this one, no changes are happening, but when we are adding 1 with this one, it is turning to fully white. And then there's like 0.5, 0.1 and all that stuff, which is actually doing a good job, where instead of having just one single circle, it is adding with different values. So we are getting this nice shape. Similarly, when you do negative, which is minus, we are going to get something like this. So if we do 1 minus this is going to give us this value, and this one is 0 minus this, basically 0 minus any value, 0.5, 0.3 is just going to be lower than 0, which is just been showing as black. This one is actually really good in creating corrosion effect, which we will learn in future when we make more stuff. So I hope you're understanding, because right now if I select subtract, if I subtract white, you're just minusing 1. As I make it go low and low, you'll see it is starting to show slowly. And you could see that as this value gets at 0, nothing's getting subtracted, right? Because we are subtracting this value with this one, and we are basically saying subtract 0, so there's no changes. And as we go up and up, we can create this weird fade out effect, where instead of having like a linear fade out where it basically fades out every single thing, we could use a subtract value to kind of give this fade out effect. You could see it slowly starts going out. You could see, and this is what we actually use a lot when we are using some kind of smokes and all. And instead of having a linear fade out, we have this erosion kind of effect, which is pretty cool. There is divide too, but I don't really understand divide, how it works. I don't really use it, but you could say it's completely opposite. It just makes it brighter and brighter. As we go down, it is fully brighter, and like this. So again, I don't really use divide much, so that's one thing you need to know. And then we have multiply, which is very basic. We are now multiplying with 1. Anything multiplied by 1 is just going to give us no changes. If anything multiplied by 0 is going to give us 0. And as we go up, you could see it is basically creating like a fade out, where each value is being multiplied by 0.5. Like if I do 50 around here, then each value is being multiplied by 0.5. So if I go down, you could see multiply 0.8. So 0.8 multiplying by 0.8 is same as saying that only use the 80% of what the original value is. So whatever the 80% of 0.4 is, it is using that one. You could see 0.8 turns to 0.64. But the best part about multiplying is that it allows you to create a mask. If you look at this example, you can see that wherever there is 0, it's basically not showing anything, because anything multiplied by 0 is just going to give us 0. So all this black area is showing black completely, because anything multiplied by 0 is just going to give us 0. Anything that is in center is completely being shown nicely, because it's multiplied by 1. And then we have like lower values like 0.9, 0.8, 0.7 till it reaches like 0.1 around here. So kind of gives us nice masking. If you want to mask something, we use multiplication. Okay, so let's start our Unreal Engine implementation. So now we have a texture in here. Again, if I do adding 1 is basically going to turn this into white color. If I do 0.2, you'd see it is slowly turning to whiter and whiter. Obviously, if you do minus 0.5, it's same as saying that do subtract. Okay, then we have multiply. Multiplying by 1 is just going to give us this stuff. If I do 5, multiplied it by 5, you could see that it basically increases the intensity of the texture basically, because if there is a value around here, let's say if I do 1, let's say this value is like 0.5. If you multiply it by 50, then it would basically turn to 25, right? 50 multiplied by 0.5, I guess it's 25 hopefully. But just know that it would turn into bigger value, because we are basically multiplying with we are basically increasing the value which is more than one, and anything that is more than one is solely going to be just white. One important thing, let's say if you are using this for opacity or something like emissive, for example, if you are using R channel for the emissive like this, maybe you thought that, okay, I need to increase the intensity, so let me just make this to 50. You could see that it can actually be like more. So if I do 1000, it can actually turn to more. It's more and more brighter, because emissive is something that can go above 1. So again, when you're doing some calculation, so think of it as a mathematical calculation when you're doing like multiple materials and textures. Let's say if you are doing, let's say, something like this where 2 texture and you're adding like this, this is basically going to make the values be above 1. Why? Because there would be some elements which in here that would be 1. In here also there would be some elements which would be, let's say, 0.5, 0.8, anything, and 1 plus 0.8 is going to give us 1.8. For some calculations it's going to be annoying, okay? If you are doing like a complex calculation or complex material or shader, then it would be annoying. For that we have something called saturate node. This is different than actual saturation, which we use in Photoshop and all. Saturate node is same as using a clamp node, this one, where it basically clamps it from 0 to 1. Okay, so adding this like this and 0 to 1 is same. Basically with clamp you can actually specify a value, but with saturate it's already set to 0 to 1. So lots of the time you will see me using saturate just to make sure that our value does not go above 1. So let's do this. Let's select this, add around here. I'm going to make this 0 because no changes. And again, I'm using the texture in R channel. Now if let's change this to a leaf texture. Okay, now if I take this one and add it in the A, guess what just happened? This was 1, so it is basically adding this stuff around here, like 1 1 1. So everything around here, it just turned to white color. If we were using, let's say, a cloud texture, which is the same one, and I'm going to use the second texture that is available in here. So here you can see I've connected R, and here I've connected G. We are doing the same stuff that we did before, which is adding like some values, but instead of adding one single value to the whole of this stuff, we are adding a texture like this with different pixel values for the corresponding area. Another thing, if you guys don't understand some stuff, if I connect just one single value, which is 0, it would turn to black. If I do 0.5, you can see it is grayish color. If I do 1, it's going to be white. If I do 0.2, it would be slightly grayish or blackish, and like this, a darker color basically. So again, this is all a thing about float values. If I do multiplication, one cool stuff, if you press this bottom arrow, you could see we can actually see the texture. And don't worry if it shows in red color, just think of it as black and white, because in the end this is just a float value, which is one value. Okay, so you could see that when we do multiply, the effect is different, because now we are doing something like this, where we are multiplying one texture. I don't know if I've shown multiplication like around here. Okay, so we are basically doing multiplication like this. So if I want, I can select a radial gradient exponential, which basically if I connect to base color, you would see this is how it looks. I'll connect to multiply, and you can see that we can use it as a mask. It only shows this, which one am I using? Let's delete this. Okay, so it only shows this much in the middle area, like this texture in the middle area. You could even see in here where I added 2 texture, which is added a radial gradient and just connected a add node between both of this, like this. Multiplication again I've already shown. And before we proceed, I want to actually show you subtract. So let's do subtract. And for this, I think I should connect the radial exponential above, which is this radial gradient, and then connect this R around here, and let's see if that works. Okay, and you could see we, instead of having like that roundedness perfectly, we actually have some different stuff. And a quick thing that we will do soon, but I want to show one thing. If I connect a panel and add one in here, you can see we get some nice effect. But if this was a multiply, like this, it would be consistent. You could see it is consistent like this. So there are cool stuff that you could do with some calculations. Now before we proceed, I want to show about something called Lerp node, which you could basically press L and get it, L plus left click. Lerp node is nothing but linear interpolate. Linear interpolate is nothing but when you want to smoothly transition from one value to another. A gradient is a linear interpolate, so you could see that this linear gradient, which is around here, it is basically going from 0 to 1, which is a linear interpolated value. So linear interpolation is nothing but basically going from one value to another smoothly. And the way linear interpolate works is that it requires a alpha. Okay, so before I do that, I'm going to add two constant 3 vector. You could press 3 and do left click or search for constant 3. Let's connect this on both of this pin. For the top one, I'll make blue, and for the bottom one, I'll make red. And I'm going to turn this alpha to 0. And if I connect to base color, it is showing me blue. If I turn this to 1, it is going to show me in red. So alpha basically takes 0 to 1 value, and which is why I said that lots of the time you will be using Lerp after doing all this calculation to add some colors. Add a saturate node so that it does not go above 1 and all, and does not go below 0. Now if I do 0.5, it is actually pink because it is halfway between all of this. So if we were using, let's say, a software where we select this blue color at one end and red color at the end, in the middle it would be this color. If I do 0.2, it would be closer to the bluish color, but it's slowly getting this red color. So it's basically going from one color to another slowly as a gradient. This alpha, we can actually specify a texture, because in the end this is 0 to 1. We know that black is 0, white is 1. So if I connect this to here, guess what? Wherever there was black, anything that is connected to A would be added in here, which basically means that wherever there was 0, it uses A pin, and wherever there is 1, which is white, it uses this pin. So you can see this is how it looks. Now if I turn this into a cloud texture, because in this one we do not have, grayscale values, you could see this is how it looks. So there are red and blue, but actually there is also a slight mixture of stuff. It's not much noticeable or understandable, but there is actually mixture of stuff. One important thing, this is something that I should show, which is called break float out 2, and if I add R, we get 0 to 1, right? There is a node called step. If I connect this, nothing's happening, but if I do let's say 0.2, what this is doing is that, so anything that is below 0.2 is turned to black, and anything above 0.2 is turned to white. And I think it also depends on which pin you are using. Are you using like X and Y, right? Yep. So you could see if I could change this pin, it also changes the direction. So this pin can actually be useful to create, let's say, some kind of shape where we only want to use, let's say, 0.1 till here and 0 till here, like this with a gradient. This step node is very useful, so I just wanted to show quickly. Now we learned some stuff already, so let me connect this where we are using multiplication, we are using radial gradient, and we have a texture which is creating a material basically around here. If I add a panel like I showed before and add 1, it basically moves it up. If I now connect a linear gradient alpha around here, and if I connect two colors, let's make this bluish and let's make this pinkish, connect this to B, connect this to A, you could say this is what we are getting. Wherever there is black, we are actually using this value, and wherever there is white, we are using blue value, like this. Most of the time you would not have something like this, and you would actually be using a translucent or mask material. So let's try translucent, and remember opacity does not require this color. This one is basically 3 by 3, like float 3. Opacity is just one value, which means it's float 1. This one is float 1 because this one is basically giving us a black and white value, right, around here, like this. So if I connect this to opacity, we get this stuff. Now one thing you might notice that because we are using opacity, anything that is black would not be showing. So lots of the time the bluish color is not been shown, but there is going to be slightly visible stuff because 0.5 0.1 is visible, you know. But this is usually what you do, you use like multiple stuff. Let me go into my preview scene and disable it, and you can see this is how it's going to look. You could even connect the lerp to the emissive to make it even more noticeable like this. Subtract is obviously going to look even better, where we take the top value and subtract some values in here like this and do alpha and connect this into the opacity, and we get this cool flame like effect. You could see. Let me connect my B channel because this has like lots of black stuff. So you could see, because I have lots of black stuff, we get some nice stuff around here like this. And again, if I, let's say, remove all of this, let's remove the pan too and do subtract to the R channel, connect this to opacity. Let's subtract 0, so no changes. Subtract 1, 0.1. It's removed some stuff. 0.2 remove more stuff. 0.5 removed more stuff. 0.8 removed more stuff. Which means that if you take a texture, you add let's say a time node, because you know time node goes from 0 to 1, and obviously we shouldn't add it directly because that would just show nothing, because it's going 0 to like 1 2 3 4 5. We don't want that. Connect a fract node like this, and you could see we constantly see what's going to happen. Usually when you are using a particle emitter and all, we don't use fract node to do this. Fract node is usually good for like something which is like constantly running or looping in this case, okay, at least in this case. But for the case of when we're using, let's say, Niagara system, we will use something called dynamic parameters, which would control it in the particle emitter itself on how this changes. That we will learn in future, okay. So you could see I've even written in here using subtract to create erosion effect. So if we now use that corrosion in a particle system, you can see how it just disappears around here. And you can see this is the material that I used previously, where nothing's happening in here except it is just moving up. I'm basically doing subtract that we have already learned. And you guys don't need to worry about anything right now about this stuff, because we will be learning this in future. But to give you a quick explanation, this particle color gets whatever color is applied around here, which is this pink color, and then we multiply it with this one. So whatever the particle that is added by our Niagara system gets multiplied and used around here with the texture that we have in the emissive property. And then I have a dynamic parameter that I said before, where we can actually control the disappearing, which is if I go in here and go into this stuff, this dynamic material parameter, you could say it goes from 0 to 1. Remember I showed that when you subtract something like 0 to 1, it starts getting disappearing because we are creating an erosion effect. For example, if I go into this bond rate and maybe keep it only 1, you could see the effect, okay. So if I go into the dynamic parameter and maybe make this be 1 so that there's no changes, 0, so that there's like no changes, you could see we are now just seeing the whole stuff, which is same as this much, you could see. But when I do this, it goes from, so it goes 0 to 1 as the lifespan of the Niagara emitter goes like this, okay. And this is all something we will learn in future videos. I just wanted to showcase that as this time, which is like randomized, which is like 0.5 to 1 second, it is basically just making this go 0 to 1. So this value is basically just, we are doing subtract. For example, in here, if you look at this, where I don't know if I can make it big, okay, there we go. So here you could see that as I increase these values, it starts getting low and low, you could see. And I've already shown this. So this is exactly what we are doing. Instead of manually adding it, we add a dynamic parameter called erosion like this, and then we go into the erosion parameter in the dynamic one, and we basically make it go 0 to 1 for this lifespan. which means that it's going to disappear. And then obviously if you make the spawn rate to be something like 50, we get some nice effect like this. So yeah, that's all going to be for this video. I will explain more stuff as we progress, and it's much more fun to learn it as we make something instead of learning the theory. But for this video I wanted to teach theory so that the next videos are going to be easy to explain, and I don't have to go like much more in detail for the next videos. And again, please go and check out this page. I will keep updating it. I still need to change like lots of stuff in here. So yeah, that's all. Consider liking and subscribing, and yeah, thanks for watching. Goodbye.